Okay, what if I told you that the legendary, totally fictional middle-out compression algorithm from HBO's Silicon Valley was basically real now? Seriously, Google just dropped a paper on a new technology that is so ridiculously close it could completely change the game for artificial intelligence. So let's get into what's really going on here. Look, when the CEO of a massive company like Cloudflare says something is a DeepSeek moment, you know it's a huge deal. He's basically shouting from the rooftops that this is a major leap forward, one that could totally reshape the entire industry. The stakes? Yeah, they couldn't be higher. But here's the thing, with all the hype, all the memes flying around social media, there is a massive catch that almost everyone is missing. And honestly, it changes everything. So stick with me, because we are going to dig into what the actual research paper says. To really get why this breakthrough is so important, we have to talk about the giant problem it's trying to solve. You see, modern AI, especially the large language models we all use, has a pretty crippling addiction to memory. At the very heart of this problem is something called the KV cache. Now, don't let the name scare you. Just think of it like this. When you're having a conversation, you have to remember what was just said to figure out what to say next, right? Well, that's exactly what the KV cache does for an AI. It's its short-term memory. And while it's absolutely crucial for the AI to function, it's also a monster that just devours insane amounts of super expensive computer memory, or RAM. So just how much memory are we talking about? Brace yourself for this one. In a lot of AI models, over 75% of the memory is being used just for this short-term memory. That is a crazy bottleneck. It's the very thing that makes AI so expensive to run, so slow sometimes, and keeps it locked up in these giant data centers. But what if you could just shrink that bottleneck? What if you could pull off some kind of digital magic trick and make that memory footprint tiny, all without losing any of the AI's smarts? Well, that's pretty much exactly what Google is claiming they've done. So let me introduce you to TurboQuant. That's the name of Google's new technique. And it's a really brilliant, almost elegant solution to this huge memory problem. So how does this magic trick actually work? Well, it's this awesome three-step process. First, they laser focus on the real problem child here, that massive KV cache. They ignore everything else. Second, they use a brand new technique to quantize the data. The best way to think about this is like taking a super high-res, gigantic photo file and saving it as a much, much smaller JPEG. Yeah, you might lose a teeny tiny bit of detail, but the file size is drastically smaller. They're basically compressing the AI's working memory. And finally, this is the clever part. They use a special optimizer to go back and sharpen the most important details in that compressed memory, making sure the AI doesn't get any dumber. The result? They shrink the memory without shrinking the model's brain. And the result of all this is, well, it's nothing short of amazing. This isn't just a tiny improvement we're talking about. This is a fundamental shift in the entire economics of how AI works. 6 times. Let that sink in. They reduced the size of that massive, power-hungry working memory by at least 6 times. Just think about that for a second. The single biggest resource hog in the whole system, the part that was eating up over 75% of the memory, just became 6 times smaller. And this is what a change like that could mean for you and me. It means running these powerful AI models could get way, way cheaper. It means we might see much faster response times from chatbots and other AI tools. And maybe the most exciting part, it opens the door to running some seriously powerful AI on smaller devices, like your phone or your laptop, without having to connect to a huge energy-guzzling data center. Okay, so this sounds absolutely incredible, right? Like world-changing. So, problem solved, let's all go home? Well, this is where the story gets really interesting and where we need to separate the internet hype from the cold, hard reality that's actually in the research paper. I mean, with a 6 times reduction, the AI memory crisis is over forever, isn't it? Yeah, not so fast. This is the part of the story that's getting totally lost in all the excitement, and it is, without a doubt, the most important piece of the entire puzzle. Okay, here's the crucial context that everyone seems to be missing. The hype you're seeing online makes it sound like this solves all AI memory problems. The reality? It only helps when you're running an AI, what the pros call inference. It does absolutely nothing for the colossal task of building and training an AI in the first place. Some people are saying this could fix the global chip shortage. Nope. Training these models still requires massive armies of the most powerful chips on the planet. And the biggest reality check of all, this isn't a product you can just go download today. It's a research paper, a brilliant, amazing breakthrough in a lab for sure, but it is not on the market. At least not yet.
But listen, this catch isn't a reason to be bummed out. It's actually the opposite. It shows us exactly where the next frontier is. It perfectly frames this breakthrough not as an ending, but as a super exciting beginning.
So, what happens next? Well, today we have the research paper. Next month at a major AI conference, the smartest people in the field will get to poke, prod, and really dig into these findings. And from that moment on, the race is on. The race to take this incredible idea out of the laboratory and put it into the products and services that you and I use every single day. So in the end, the real question isn't really about whether Pied Piper is finally real. The much bigger, much more exciting question is this: what happens when the physical limits of computer memory are no longer a boundary for our digital imagination? That's the future this points to, and it is going to be absolutely fascinating to watch